morning. So, today I told you that we will discuss these compounds which are known as dendrimers, but dendrimers I will discuss later, because for continuation of what I am talking about, for that today we will discuss interlocked structures. So, we will discuss interlocked structures. It will take more than one lectures to complete these interlocked structures. Let me draw the cartoons of interlocked structures. You have a rod. I have already introduced it in the very first lecture, but I am repeating it because we will discuss it now. Okay. So, maybe it is not very visible. So, I will do like this. Okay. So, this particular interlocked structures, we have one macrocycle and one rod. So, this rod threaded into macrocycle, and this is called pseudo rotaxane, pseudo, because it is not really truly a rotaxane, but it is a pseudo thing. So, that is why pseudo rotaxane. Okay. And it is really, we will call it 2 pseudo rotaxane. Why 2? Because this is 1 and this is 1. We have 2 components. That is why it is 2 pseudo rotaxane. Then if this is pseudo, then what is actual rotaxane? This is the structure of rotaxane. Okay. Maybe I will again try differently. Let me put it okay. Now, okay, and at the end I have big groups. So, these big groups, they are called stoppers, they are known as stoppers. Stoppers. This is a stopper and this is another stoppers. So, here you can see that once it is in, this macrocycle is inside this rod, it cannot go out very easily. Maybe I can draw it little bit bigger, these stoppers. So, really impress upon you that the macrocycle cannot go out. And this, then what is the name of this particular interlocked structure? This is 2 rotaxane. Two rotaxane. is not rotaxane. This is also no S, is a 1. So, okay. So, this is 2 pseudo rotaxane and this is 2 rotaxane. Here is no pseudo business, here is a rotaxane. So, that means a rotaxane is a particular supramolecular compound where a macrocycle can enter this, can enter a rod like structure, a linear rod like structure, and once it gets in, it cannot be taken out easily. Okay. Sometimes what happens, sometimes you how to synthesize this compound. Okay. As you can understand, when I have this pseudo rotaxane, I take a macrocycle and then put the rod inside. Okay. Put the rod inside. Why it will go? It will be obvious as we go along. And once it goes in, then I can put stoppers here and stopper here to get rotaxane. All right. Let me write the 2 others, and not only that, you have this compound. Suppose this compound, I am writing it. This is a linear rod, It is a linear rod, but I have drawn this 2 pattern just like that. And here you have also another unit, here is another unit, yeah. Okay. And then what can happen? You can put one here and one here connected, and then you can put one here and one here connected. So, this we will call poly pseudo rotaxane. Poly pseudo rotaxane. Poly pseudo rotaxane. And so, how this is formed? This is basically you have 2 macrocycles connected, 2 macrocycle connected, and I take 2 linear units and they will go inside. They will go inside to form this. Okay. And why they will go here and here? Because I have something here, because that is why I have drawn this, pattern. These are the place where it will stop. Why it will stop, I am coming in a minute. Okay. One will stop here, another will stop here. All right. Then another interlocked structure is so this is also another interlocked structure. This is 2 double helix. Double helical structure. double helical structure. Similarly, we can have triple helical structures. Writing a helical structure is somewhat difficult, but you can imagine that one goes like this, the other will go on the other way. Double helical structure, you have some idea from DNA, okay, DNA double helix, and there are triple helix also structures are available, all right. And here you can have metals, metal helicates, you can have metal, metal. So, those kind of structures is difficult to draw, but they exist, and I will try to give some photographs in my notes, so that you can have a better understanding of double helical, triple helical structure. Okay, now, let us go and see how can we synthesize pseudorotation. Here I have a linear molecule, okay. It is not really very difficult to synthesize this kind of molecules. So, you do not worry about these things. My aim is not here to show you details of the synthetic methods, but just to tell you that it is indeed possible to have such structures. Then what I get, maybe this is on the up or down does not matter because of free rotation. How many I have done? 1, 2, 3, 1, 2, 3, both sides. So, this is my linear rod like compound, one component, fine. Now, I put this is N here, maybe I will write little bit better, N. Okay. Okay, both this nitrogen will be positively charged. Okay. Then As I always said, my drawings are not world's greatest, but at least for understanding okay. So, this is an aromatic also, okay, and this is a macrocycle. I have drawn it like that, but actually you can write almost like this macrocycle. Yeah, you can write a macrocycle like a rectangular type. Fine. Then what I do? This plus this plus this, and if we cook it with this, you cook it with a say acetonitrile at high temperature for several hours, then what will happen? This linear will go there, will go inside, this linear will go inside, okay, it will go inside. Why it will go inside? Because this linear has these two aromatic moieties, which are and these are also 4,4- bipyridinium moieties. This 4,4- bipyridinium is electron deficient, and these are not electron deficient. So, electron deficient and electron rich, they will have pi stacking. I told you that pi stacking is another, let us have a pi stacking here. Let us have a pi stacking here and here. So, it is now in. Unless it is in, this linear will not be in good pi stacking mode with this and this together, because I want a pi stacking mode with both. So, that is why it must go in. So, that will make a pseudo rotaxane. Once it forms pseudo rotaxane, then what I can do? I can take 2,6-dimethyl pyridine base, 2,6-dimethyl pyridine base. I take in presence of 2,6-dimethyl pyridine base, okay, 2,6-dimethyl pyridine base, I react this pseudo rotaxane with this silicon OTF. Isopropyl group with tris isopropyl tosylate. So, this tris isopropyl tosylate, what will happen? It will react, because at the end what I have? At the end I have OH and OH, remember. So, this will react in presence of pyridine as a base, it will react and then it will come here, because tosylate is a good leaving group. Okay. So, it will go and here I have silicon my stopper, and so is here also. Here and here I have silicon and stopper. I am not writing this. Okay. So, but here also same thing. So, these are now stopper, and stopper are somewhat much bigger than OH. So, what will happen? This macrocycle will not easily come out, and that is why it is rotaxane. So, rotaxane is synthesized. Okay. So, now that I talked to you in some details about the synthesis of these rotaxanes, my next job will be to show you. So, that was 2 rotaxane and first 2 pseudo-rotaxane and then 2 rotaxane, and they can be crystallized also as PF6 salt. Okay. So, another method is already this another method is this compound, linear compound is this. These are actual compounds people have made. T-butyl group, T-butyl group. Okay. All right. And now, O, and then I write here okay. Here I put a R group. R is not a T-butyl group. Okay. Therefore, okay, then okay, and then I put same. Okay, I do not have much time, so I can put the same thing, or maybe I will write what is there. So, we write there and then O, 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 these are very crucial points. For example, I am writing R here, and this, you see, I have written a aromatic groups. Same thing here. I have already synthesized a rod like unit with two stoppers at the ends. Now, what happens here? Earlier I had silicon and all that, but now here the stoppers are different. It requires somewhat less. It requires somewhat less area, so that something can get inside here. Now, when that is, this particular compound is reacted with this macrocycle. I am drawing this macrocycle O, then 1, 2, 3, 4, 5. Everything is very important. Why not 4? 4 will not go in. Why not 6? 6 will go in, but come out also, little bit easier. So, 5 is optimum. It can be done with molecular mechanics calculation or even experimentally. Or experimentally. So, this can go. This is a big size. Okay. If you take bigger size, it will easily go, and if you take a smaller size, it will not go. So, 5 is optimum. This can be calculated by molecular mechanics and do that. So, here the difference from the previous one we could have taken a smaller also, but here we have to take this big macrocycle, and if we put there, the condition is that, look at the condition, in acetonitrile solvent, reaction at 55 degrees Celsius for 10 days. That means, for 10 days we have to pound. Okay. We have to pound, and if you do that, then it will form as such. How it will form? It will form like this. No, I made a mistake. Directly oxygen, 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 and here you have oxygen 1, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, this one. Okay. So, this one is here. Why this one is here? Because this is electron deficient, and oxygen has electron, 2 lone pairs. So, those lone pairs it can donate to this nitrogen, and it is like this. It can be obtained as 2PF6 salt, 2PF6 salt, because it is a dye positive. So, it is a dye negative. So, here these things are important. Important is your stopper, the shape and size, this is very crucial. shape and size of the stopper is very crucial, and also shape and size of the macrocycle. Okay. In the previous case, I had electron deficient macrocycle. I had electron deficient macrocycle and electron rich linear. So, it went in, okay. It went in and form this pseudo rotaxane. From there I could get rotaxane, but in this present case it is somewhat stringent, because it is already stoppers are already there. Now, you can say that if in spite of stoppers at the two ends, this macrocycle is going in, that means it will come out. Of course, it will come out, but coming out is not very easy, because you can say that going in means for 10 days at 55 degree Celsius, I am pounding it. Okay. So, we stop here today. So, next time other systems I will describe. Thank you.